Chapter 3.2, Polynomial Functions and Their Graphs. And this is going to be a little bit about graphing and a little bit about finding zeros or x-intercepts. So we start out with something really simple. Give the degree and the leading coefficient of each of these expressions. Well, when we're looking at this, now let's start with b, because my highest degree here is 2. And the multiplier of my highest degree term is -8. It's not in standard form, so you want to make sure that you identify the highest degree. Going back to a, though, really I'm multiplying x times -x to the third times 5x to find that multiplication will happen. We don't have to do all of them. We just have to consider what happens when we multiply those three things together, because that will give us our highest degree term and whatever's the coefficient is our leading coefficient. So x times x to the third times another x, we're adding those degrees, so we get a 5th degree polynomial. And our leading coefficient is going to be 1 times -1 times 5, or -5. The next topic, and this is why they have you identifying the leading coefficient and the degree, is so then we can predict the end behavior. And we did this in Algebra 2, that's good, but I'd be surprised if you remember a whole lot of it. So there's actually only four possibilities, and it depends entirely on the degree being either even or odd, and the leading coefficient as being positive. So if the degree is even and our leading coefficient is positive, this is one example. It's just a quadratic that has a positive leading coefficient. So a reminder, we have this terminology that talks about x getting very large negative. That means it's going to the left. And so that it's basically describing the left side arrow. Well, the left side arrow is going up to positive infinity. And with even degree, both end behaviors are the same, but you can also see the right-hand arrow going up to positive infinity. Okay, let's go down to where the degree is even and our leading coefficient is negative. This is kind of a 4th degree here, but the same thing would work with any even degree, 2nd degree, 4th, 6th, whatever. Well, we can see on the left-hand side where we go to -infinity and our x's, our y is also going to -infinity. And on even degree, you always have the same end behavior on both ends. They'll both be pointing in the same direction. Let's go to odd degree. It's probably the easiest. It's a it's a cubic, x to the third, that has a positive leading coefficient. My left-hand arrow is going to -infinity. My right-hand arrow is going to positive infinity. Let's think of a odd degree. I'll just put let's put an extra. Alright, well that's pretty terrible looking polynomial. But the only point I'm trying to make is if your leading coefficient is negative, then the two end behaviors flip. So as x gets bigger negative, y gets bigger positive, and the opposite happens as x gets bigger positive. Okay, determine the end behavior of each function. We're just going to use the above pattern to answer these questions. And I have them memorized, so I don't even need to look at them. But this is 4th degree and positive leading coefficient. So as x goes to -infinity and x goes to positive infinity, y is going to go to something on both cases. So, and not sure why I didn't think of doing this before, but I'm going to need that everywhere. Okay, so back to even degree and positive. Look, both arrows on even degree are going to be pointed in the same direction, and a positive leading coefficient means they're going to both be pointed at positive infinity. A quadratic with a negative leading coefficient. Notice I'm not even looking at the other terms. I'll get both of my ends going to -infinity. And we've got a cubic that has a positive leading coefficient. So when we go to negative infinity, we get negative infinity, positive, and it switches for a odd degree with a positive leading coefficient with a negative leading coefficient. I will make that negative because I wanted to see all 4 examples. Okay, that'll do it for this video.